Alright, so today we are going to be reviewing something that we actually did back in geometry, and that is special right triangles. So if you guys remember, there were two kinds of special right triangles that we looked at. The first one we're going to talk about is a 45, 45, 90 triangle. Alright, which is also sometimes referred to as an isosceles right triangle. If you remember, what was nice about these is we were able to get more exact values with only possibly one side of our triangle. So they followed a specific ratio where our two legs of our right triangle were always the value of x, and the hypotenuse of my triangle was x times the square root of 2. Remember, that number in front of your radical just means it's multiplied together. So if I were to have, this is going to become important a little bit later on next week, if those x values were 1, then my two legs of my triangle would be 1, and the hypotenuse of my triangle would be the square root of 2. Okay, so let's look at our first example here. This tells me that one of my sides is 3 and my two legs are the same. So actually, you don't have to use 45, 45, 90 triangles on this. You guys can see that since those two sides are congruent, that you can just use the Pythagorean theorem. But to get used to refreshing on how we actually did these back in geometry, we're going to go through and actually solve it as a 45, 45, 90 triangle. And what I want to do is I want to find AC. I want to find that missing side. So there's a couple different ways you guys could do this depending on how you learned it in geometry. What I like to do is when I do a special right triangle is I set up a chart. And what I do is I put my angle measurements at the top. So I've got 45, 45, and 90. And then I fill in my ratio. I've got x, x, and x square root of 2. And the side that I know I'm going to fill in. So I know 3. 3 is across from 45 degrees, which means that 3 is my x. So now I can look at my chart and just fill in all those x values that I already know. So that means my other 45 is going to be 3, and my 90 side is going to be 3 square root of 2. The side I'm trying to find is AC, which is across from 90, which means that AC is 3 square root of 2. And remember, that's 3 times the square root of 2. It actually has a specific value. If you want to put it in a calculator, you can get the actual decimal value. But leaving things with square roots, that's actually the simplest answer that we can get. Okay, now let's look at another example. I know this is written a little sloppy, so I apologize. But we can see that one of our angles is 90, one is 45, so this is a 45, 45, 90 triangle. And we're given the side that is 5 square root of 2. So you have to be careful on this one, because just because there's a square root, it doesn't automatically mean that it goes in my chart under the square root side. I'm still going to fill in my chart with 45, 45, 90, and I've got x, x, x square root of 2. So what I need to look at, if you guys remember, is I need to see where that falls. Is that across from a 45 degree angle or across from a 90 degree angle? And if I look, 5 square root of 2 is across and not touching that 45 degree angle. It actually touches the 90 degrees, so even though there's a square root of 2 as the value, it can't go in that 90 degree column. So 5 square root of 2 is actually my value for x. So that means my middle column is also 5 square root of 2, and that means my 90 degree column is 5 square root of 2 times the square root of 2. So if I multiply this out, anytime I have the same square root multiplied by each other, it just ends up as that same inside number. If you think about that, whenever you multiply square roots, you multiply your outside numbers together and you multiply your inside numbers together. The outside numbers stay outside and the inside numbers stay inside. So this would be like 5 times the square root of 4. We know the square root of 4 is 2. This is simply 5 times 2, which gives me a value of 10. So my missing side across from my 90 degree angle is actually 10. So the biggest thing we just need to recognize from that is simply that just because there's a square root in my value, it doesn't necessarily mean it goes in the square root box of my chart. So we're going to do one more 45, 45, 90 example, and we're going to solve for y on this one. So again, I'm going to start this the same way. I'm going to set up my chart with 45, 45, 90, and my ratio of x, x, x square root of 2. And what I'm going to do is I'm going to look at the value I'm given. I'm given 7. 7 is across from 90 degrees, so it goes in my chart in the 90-degree column. So what I need to do is I don't know the value of x right now. What I do know is I know that x times the square root of 2 is equivalent to 7. So this is just solving a basic algebraic equation. In order to get x by itself, I need to divide by what's with x. And right now what's with x is the square root of 2. So all I need to do is divide by the square root of 2 on both sides. So I find that x is 7 divided by the square root of 2. Now if you guys remember back in geometry, you had to do something called rationalizing the denominator, which meant you had to get the square root out of the bottom of the fraction. Now what's nice is actually in this class and in calculus, you actually do not have to rationalize the denominator. So you're allowed to leave those square roots in the bottom, and you can save yourself a little bit of work. Now it's still good to know how to do that in case you get a multiple choice test and you don't see this as an answer. So I am going to show you guys how to do that in case you've forgotten. So if I wanted to rationalize my denominator, what I would need to do is I would need to multiply by the square root of 2 on the top and the bottom, and then I just multiply straight across the top and straight across the bottom. So on the top I would get 7 square root of 2, and on the bottom, we talked earlier, anytime you multiply the same square root times itself, you just end up with that inside number. So I would end up with 7 square root of 2 over 2. So remember, these two answers, they're the same thing. It's just a different way of looking at it. But if you were to type both those values into a calculator, you would find that it's actually the exact same number. So either answer is going to be acceptable, but it's good to kind of know how to rationalize the denominator just in case you see it and you can't figure out where your answer choice is. But for this class, if you leave your denominator with a square root in the bottom, nothing wrong with that, that's okay. Save yourself a little bit of work. The other kind of special right triangle that you guys learned about in geometry was a 30, 60, 90 triangle. So that also had a special value to it. And these are important when you want to get exact answers and you're only given one side of this triangle. So I couldn't actually use the Pythagorean theorem on this one, where I possibly could have with a 45, 45, 90. So if you remember, the ratio for these triangles, across from 30 degrees is x, across from 60 degrees is x times the square root of 3, and across from 90 is 2x. So if I was to take this triangle, I'm going to turn it around the other way because sometimes you don't just see it that way. I'll call this my 60 side. If I were to fill in a value of 1 for x, across from 30 would be 1, across from 60 would be 1 times the square root of 3, and across from 90 would be a value of 2. So I'm going to start off with a pretty basic example. Let's say I have a right triangle. I know one angle is 60. That means my other angle has to be 30. And let's say I'm given that the hypotenuse is 5. And I want to solve for, we'll call that C. So I'm going to do this the same way. I'm going to use a chart. And you don't have to do it this way. This is just the way I used to teach my geometry kids. So I'm going to fill in my chart with the information that I know. I know that 5 is across from 90 degrees, so I'm going to fill in 5 in the 90 column. So now all I need to do to fill in the rest of my chart is solve for x. So if I look, what I know right now, I know that 2x is equal to 5. And just like I did before, I just need to solve for x. And I get that x is 5 over 2. If you want to use decimals and do 2.5, that's okay. Just make sure if you have a decimal that's not perfect, you leave it as a fraction. Again, we're trying to get exact, precise answers, so we don't want to have any sort of rounding. 2.5 is okay because it's not rounded at all, but be comfortable with fractions. We're going to use them a lot this year. So I'm going to fill in my chart with what I just figured out. I know that x is 5 over 2, and x is 5 over 2. So that means that my 60 degree side, what I'm looking for is 5 square root of 2 divided by 3. And you could see that written a couple different ways. It could just be written like that. What you're commonly going to see though is, because that's the square root of 3 over 1, this is actually 5 root 3 over 2. And that's more often the way you would see your answer written. Alright, so for my last example, we're going to do one last 30, 60, 90 triangle. and we're going to solve this one for y. So right now we're given a 30-degree angle and a 90-degree angle, so this is a 30, 60, 90 triangle. So I'm going to start by making my chart with 30, 60, and 90. I'm going to fill in my ratios. I've got x square root of 3, and 2x. And then I'm going to fill in the information I know. I know that 5 is across from 60 degrees. So 5 goes in my 60-degree column. So what I need to do now, I need to solve for x just like I did on those previous questions. So what I know that x times the square root of 3 is the same thing as 5. So in order to get x by itself, all I need to do is divide by the square root of 3. So that means that my x is equivalent to 5 over the square root of 3. So that means my 30-degree side, what's across from 30 degrees, is going to be 5, written in the wrong place, 5 over the square root of 3. And my 2x side is going to be 2 times 5 over square root of 3. Now remember, that's 2 over 1 times 5 over the square root of 3, which is 10 over the square root of 3 is across from 90. My y that I'm looking for is across from 90, which means my final answer then is 10 divided by the square root of 3.